This is Euclid Book 5, definition number 4. Now, the official text says magnitudes, well, we have two magnitudes here. We have A, we have B. Magnitudes are said to have a ratio. Well, obviously we're saying these have a ratio, A to B, okay, or B to A, doesn't matter either way. Magnitudes are said to have a ratio to one another which can, when multiplied, exceed one another. Well, what is it saying? Okay, well, if you were to draw, now obviously you can multiply this, this 2-inch line here already exceeds this one, but you can multiply it and you can say, well, this 4-inch line exceeds the 1-inch line, and if you had 6 inches here, you would have far more than this. But can this eventually exceed this? Yes, because if you take that times 3, if you had 3 1-inch lines, okay, you have an A, that obviously exceeds B, because B is only 2 inches and this can be a lot longer. So this magnitude can exceed this magnitude, and this magnitude can exceed this magnitude. Okay? So that's what it's talking about. Now, you say, well, okay, that's all fine and cool then, but why would he say something like that? Well, what if you had a line that stretched to infinity? Now you run into a problem. Well, the infinity line obviously is going to be bigger than any finite line, but no finite line will ever exceed the length of an infinite line. Likewise, if you have an infinitesimal line, which means something that's so utterly small that you probably couldn't even see it, well, you're never going to have a line smaller than that. So yes, you would have one, if you had a 2-inch line and an infinitesimally small line, okay, you can say, well, the 2-inch line is obviously bigger than this much smaller line. That's true, but the smaller line could never exceed the bigger line. Anyway, I think you kind of get the point here. I may have not exactly said it right, but I think you're getting the gist of what I'm trying to say here. Okay? So, each one of the two lines has to exceed the other. Alright, and that's Euclid Book 5 definition 4 in a nutshell. The most important thing, though, is to remember that if you have an infinite line, you're never going to get a finite line that's going to be bigger than an infinite line. That's just impossible. Okay? I think in the infinitesimal line, we can say that no finite line will be ever smaller than an infinitesimal line. And that's true. Alright. I will tell you more in the next video, so stay tuned.